Hi everybody, Johnny here. I hope you're doing great today. You can find more good math at jmathpage.com. Today we're going to be looking at multiplying by 4's, and this time we're going to be thinking about it using an array. Right? So maybe you've seen something like this. 1 times 4, 2 times 4, 3 times 4, 4 times 4, 5 times 4, 6 times 4, 7 times 4, 8 times 4, 9 times 4, and 10 times 4. And maybe you're working to memorize all of your multiplication tables and want to know your 4's. Well, today we're going to be using an array to think about our 4's, and maybe they'll help you to understand your 4's better and help with that memorization too. So first we need to set up an array. An array usually has rows and columns, and the numbers of rows and columns depends on what kinds of problems you're working on. Well, today, since we're working on 4's, I'm going to start by making 4 rows. 1, 2, 3, and 4. So I have 4 rows. 1, 2, 3, 4. So I have 4 rows. Now I need to add some columns. Well, while rows are horizontal, columns are vertical. So let's add them vertically. Let's start over here. Let's see, how many should I do? I've done 4 rows. I probably should do 10 columns. Let's start. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I've made 10 columns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can always make these for yourself, you know. So let's write up here 10 columns. Okay, 10 columns and 4 rows. And every time a column passes by a row, there's an intersection. So that's going to be helpful to our problem solving here. Okay, so let's think about this. This first one, 1 times 4, if we're thinking about it in terms of an array, we're thinking about how many crossings are there for 4 rows when there's 1 column. 4 rows, 1 column. Well, here's our 1 column. Here's our 4 rows. So let's see what happens. It crosses here, 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 and here. Okay? So 1 column, 4 rows. 1, 2, 3, 4. We have 4 intersections. So we can say that 1 times 4, or 1 column and 4 rows, has 4 intersections. Let's continue. 2 times 4. We want to have our 4 rows to start with again, but this time we have 2 columns. So 2 columns and 4 rows. 2 columns, 4 rows. So let's find out about the intersections. Okay, I know I had 4 intersections in this first column, so now I'm going to add on 4, 5, 6, 7, and 8. So 2 columns and 4 rows. Altogether, we have 8 intersections. So 2 times 4, 2 columns, 4 rows, give us 8 intersections. What about 3 times 4? So again, 4 rows, but this time with 3 columns. 3 columns, 4 rows. 3 columns, 4 rows. Intersections? Now I know before I had 8, so let's count on 8, 9, 10, 11, 12. So if I think about 3 columns and 4 rows, all of these intersections in here, I can say that 3 columns and 4 rows give us 12 intersections. The next one, 4 columns, 4 rows, 4 columns, 4 rows, intersections. Okay, I know I had 12 before, so let's count on 12, 13, 14, 15, and 16. So that tells us that 4 columns and 4 rows give us 16 intersections. Okay, 4, 8, 12, 16 altogether. The next one, 5 times 4, we can say is 5 columns and 4 rows. All right, 5 columns, 4 rows again. Let's mark our intersections. We know we had 16 before, so let's count on 16, 17, 18, 19, and 20. So we have 20 intersections all here now. So let's look at this. 5 columns and 4 rows give us 20 intersections. So 5 times 4 equals 20. The next one, 6 times 4. 6 columns, 4 rows. 6 columns, 4 rows. Let's mark the intersections. We had 20 before, now we have 21, 22, 23, and 24. Okay, so 24. So we're saying that if we have 6 columns and 4 rows, all of these intersections, 6 columns and 4 rows, give us 24 intersections. 7 times 4, 7 columns, 4 rows. 7 columns, 4 rows. Let's mark the intersections. We've added 4 more, right? So 24, 25, 26, 27, 28. So we can say that 7 columns and 4 rows give us these many intersections. So 7 times 4 gives us 28. 8 times 4, 8 columns and 4 rows. Well, let's see. 8 columns, 4 rows. Mark the intersections. Okay, counting on again. 28, 29, 30, 31, 32. Alright, so 32 intersections altogether. 8 columns and 4 rows give us 32 intersections. 9 times 4, 9 columns, 4 rows. 9 columns, 4 rows. 32 before, let's count on. 32, 33, 34, 35, 36. We have 36 now. So we can say 9 rows, we can say 9 columns and 4 rows, or 9 times 4, give us 36 intersections. Okay, last one, 10 times 4, 10 columns, 4 rows. 10 columns, 4 rows. Let's add the intersections. Alright, so let's count on again. 36, 37, 38, 39, and 40. Okay, so looking at all the intersections now, 10 columns and 4 rows. 10 columns and 4 rows give us 40 intersections. So we can see with the array that every place where a row and a column meet gives us a count toward the multiple of 4 here. Right? So an array is a useful way to think about multiplication. So let's look at these over here. Okay? I want you to look at them for a moment because I'm going to erase them and you're going to have to remember them. Now, you don't have to remember them without anything to look at and have a clue about what you're doing. Now, I've left the array here, so you still have the array over here. But what I'm going to do is I'm going to ask you to remember what these multiples are. So if I start here, I'm going to say 1 times 4 equals, and you're going to say what it is. So let's start. 1 times 4 equals, 2 times 4 equals, 3 times 4 equals, 4 times 4 equals, 5 times 4 equals, 6 times 4 equals, 7 times 4 equals, 8 times 4 equals 9 times 4 equals, and 10 times 4 equals. How'd you do? I bet you did pretty well. Now let's do this one more time, but let's mix it up a bit. Are you ready? I'm going to start with 3 times 4 equals, 8 times 4 equals, 2 times 4 equals, 9 times 4 equals, 1 times 4 equals, 10 times 4 equals, 7 times 4 equals, 4 times 4 equals, 6 times 4 equals, and one more, 5 times 4 equals. How'd you do that time? Let's look them over again. Are you ready? 1 times 4 equals 4. 2 times 4 equals 8. 3 times 4 equals 12. 4 times 4 equals 16. 5 times 4 equals 20. 6 times 4 equals 24. 7 times 4 equals 28. 8 times 4 equals 32. 9 times 4 equals 36. 10 times 4 equals 40. I bet you did pretty well with these today. Remember that an array is another way to think about multiplication. And it's all about rows and columns. Rows and columns. Alright? And it's another way to think about how to find the multiples of any multiplication pairs you're interested in. Alright? I hope this was helpful to you.